Hello everyone, I am Mrs.Kulkarni from Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. In previous session you have seen what is semaphore and how it gets rid of the problem of shared resource or shared data, which is very important service provided by the operating system. But again, while using semaphore, there is a problem of inverting the priorities of a task called as priority inversion problem. So how it occurs and why it occurs? So it widely occurs in the case when you use the semaphore. So we have seen in the semaphore we are getting the CPU time or your shared resource time to a particular task based on when it is ready to run. So once it is ready to run state, it will be preserved in the queue and accordingly key is provided, nothing but access is provided to the task. But while doing so, we are disabling the task scheduler because we want to get rid of the problem of interruption, and that's why priorities will be preempted over there. So while doing so, priority becomes inverted and deadlock develops in certain situation. So what is deadlock? Deadlock is nothing but when there are more than one task want to access the same resource, then priorities will not be observed, but its status in a ready to run state in a queue will be observed. So in this instance, while holding the semaphore for too long time, there may be the problem of priority inversion. So suppose, see here the figure from the book, David Simon book, where right now task C is holding the semaphore. Task C takes a semaphore and the same semaphore or the same resource to be shared by the task A. Now you can observe here task C is at the lowest priority, task B at the medium priority and task A at the highest priority. But once task C is acquired the semaphore, then it will not release until it completes its task. So you can observe here task C is holding the semaphore for too long time. Now once task C completed its work, then now task B will hold your semaphore as it is already in the queue. So task B gets a message in the queue and it unblocks auto switches to task B. Now once the task B completes its execution, then task A gets the message in its queue and unblocks auto switches to task A. So it will happen because task A appeared in a queue at the end, nothing but after task C and task B. Now task A tries to take a semaphore that task C already has taken. Now after task A is over, now task B will be requesting for the semaphore, and so task B goes on running and running until it's complete its task, and so task A is blocked. So you can observe here requests are there but priority will be given to the task which is present in the queue for using the semaphore. So here this problem is called as priority inversion, where priority will be given to the lowest priority task. So this problem can be solved by using various methods like disable the interrupts to protect the critical section. So once you disable the interrupt, there will be no problem of critical section, nothing but shared data problem. So you can have the priority ceiling, means there should not be any variations in that, or you can interchange your priorities with the help of priority inheritance. So it is nothing but temporarily boost the priority of task C to that of task A whenever task C holds the semaphore and task A is waiting for it. So automatically priority will be given to task A. Fourth one is avoid blocking of the your task, and last one is random boosting. So priority inversion is nothing but deadlock situation which can be controlled by these many techniques. So you have to take care while assigning the priorities to a task. So we will see the problem or the concept of priority inheritance in the next class. Thank you.